Hello everyone. In this video clip, I will be presenting my AI mini project, which explores the application of heuristic search algorithm in emergency evacuation system, specifically in the case of a fire. Let's begin with the scenario. Imagine there are fire in a corporate office building. To ensure everyone's safety, we need a smart evacuation system that can quickly find the shortest and safest route to an emergency exit. For this, we use heuristic search algorithms which consider hallway distance and emergency fall direction to guide people to safety. The first method, we apply the greedy best first search. This algorithm always chooses the next node based on the one seem closest to the goal. It uses the heuristic function fn equal hn, meaning it only considers the estimated distance from the current node to the goal. It's fast, but not always optimal. Next, we have the A-star search algorithm. Unlike greedy best first search, A-star considers both the course already taken and the estimated remaining distance. The formula is fn equal gn plus hn, where gn is the cost to reach the current node, and hn is the heuristic estimate to the goal. This balance allows A-star to find more efficient and often optimal paths. For this project, we are using the graph searching applet version 4.5.3 from AI Space. It allows us to visualize search algorithms such as A-star and best search in graph based on environment. We are modeling a building layer to simulate a fire escape scenario. We begin by creating nodes for each location inside the building. For each node, we enter a name, assign a heuristic value, which is an estimate of the distance to exit, and define the node type. In our example, we define main office entrance at the start node and emergency exit at the goal node. Next, we connect the rooms using edges. Each edge represents a possible path and its cost, which could reflect distance, time, or difficulty of traverse. We repeat this process until all nodes are connected based on the building layout. Okay, we now run the algorithm using greedy best first search. We begin by clicking step to manually observe how the algorithm expands the most promising nodes. In this case, greedy best first search should node based only the heuristic value or hn. It doesn't consider the cost so far. After a few steps, we click auto search to let the algorithm continue until it finds a complete path to the goal. For A-star, we run algorithm using A-star search. A-star search uses both actual cost and heuristic values to find the most efficient path. Just like before, we use steps to manually go through the early expansions. This shows how A-star evaluates nodes one by one based on the formula. Then we click auto search to complete the process. The algorithm has found the best path from main office entrance to the emergency exit, shown in red. This path balances actual travel costs and estimated distance to exit. The final path cost is shown at the bottom, and the highlight node indicates the route taken. In conclusion, after running A-star search, the algorithm successfully found the shortest path from the main office entrance to emergency exit. The path is main office entrance to reception, to maintenance room, to control room, to survey room, and emergency exit. This path had a total cost of 28 units and required 18 nodes to be expanded. It shows A-star evaluated nodes based on the formula, balancing both the path cost so far and the heuristic estimate to the goal. This makes it more thorough and optimal. Greedy best first search only uses the heuristic to guide its search, which makes it faster but not always optimal. In this case, it happened to choose the best path, but it is not guaranteed in general. And that's all for my AI mini project. Thank you for listening.